as in terms of x and y. Okay, we learned doing this, and I told you if you know how to balance an equation in terms of x and y, you should remember this. Okay, that is one thing that I discussed. And if you know this, you can simply solve the question kind of very easily. So we're going to try and do this one. Okay, yahan pe na what he has done is we're just going to try and solve these questions in this class. So is Sidra here? So we're going to just try and solve these questions. Remember, an unknown hydrocarbon, the equation is balanced in this way. The way is shown in the screen. So the question states, okay, there is 25 cm cube of a gaseous sample of P, this CXHY. So they've stated that this is 25 cm cube. That is already mentioned here. So this one over here is 25 cm cube. And he's stating that it reacts, the sample is burned completely in 200 cm cube of oxygen. So the amount of oxygen that you have is 200 cm cube. But he's using the word, I mean, if you look carefully, he's specifically using the word excess. That means, what that means is it's not the actual amount of oxygen that's taking part in the reaction. 200 cm cube में से थोड़ा सा oxygen react हुआ होगा, ठीक है, not all of it, because it's added in excess. And then the final volume measured, and so this reaction happens, and you have a final volume. The final volume of the gases. So saying that the final volume measured under the same condition as the gaseous sample was 150 cm cube. So what is this 150 cm cube? Okay, so once this reaction happened, the final volume of the mixture was 150 cm cube. So remember the reaction is happening at 37. So that means water is not going to be gaseous. So that is out of the question. Okay, water would be in liquid state. So the final volume of the gaseous mixture will not have water, because water is not going to be a gas in the first place. So what will it have? It will have the carbon dioxide that's produced. Water the बीच में से निकल गया. Final volume of the gas जो है. Is this clear? यहाँ तक clear है? Is this clear? Maz, Ahmed, Amna, is this? So the final volume will have carbon dioxide and the leftover, the remaining oxygen, because remember he told us that it's in excess. So there's going to be leftover O2 as well. That's still present. So this 150 cm cube that you have, it's got two things. It's got carbon dioxide as well as oxygen gas. And it's that oxygen gas that's left over after the reaction. Now we're seeing that treating the remaining gaseous mixture with concentrated alkali to absorb carbon dioxide decreases the volume to 50 cm cube. So iske andar se na, he removes carbon dioxide. The concentrated alkali absorbs the carbon dioxide. He removes CO2 and the volume decreases to 50 cm cube. So first thing is, what does that indicate? Okay, how much carbon dioxide was present? Okay, originally the volume was 150. And then when you try to remove the carbon dioxide, the volume drops to 50. So how much carbon dioxide was present over here? What is going to be the answer?
100.
Okay, so it's going to be 100. Okay, that's just 1 second. So it's going to be 100, right? So that's going to be 100. Or idhar hum kar lete hain ke, so that means the amount of carbon dioxide is actually 100 cm cube. क्योंकि the volume dropped to 150 से it immediately one second. So it immediately decreases to 50. So that means there's 100 cm of carbon dioxide that's missing now. So 150, what's the left? What's the other thing? That would be your 50 cm cube of oxygen. This का मतलब है, what does that mean? Okay, you started off with 200 cm cube of oxygen. So there is 50 cm cube of leftover oxygen at the end. That means what is the amount of oxygen that's actually taking part in the reaction? That is 150 cm cube. Okay, so I'm going to explain this a bit slowly. That initially you added 200 cm cube in excess. When the whole reaction was over, there's still 50 at the end. That means you started off with 200 cm cube in excess, and there's 50 remaining at the end. So the amount of oxygen that actually took part in the reaction was 150. Is this clear? Ahmed, is this clear? Amna, is this clear?
Yes.
Can you please explain the statement written above कि ये जो लिखा हुआ है कि same condition as the gaseous sample so that the water produced is liquid and its volume can be ignored. तो वो liquid का नहीं कह रहा है?
नहीं, first thing is water तो मैंने निकाल दिया ना, क्योंकि the temperature that he had given us was 37 degrees centigrade, right?
Yes, sir.
तो वो जो gaseous sample का volume है ना, which he's talking about, the final volume of the gaseous sample, ठीक है? So it's not going to have water vapors in it, ठीक है? Because water would be liquid at 37. That's clear, right?
Yes, sir.
Okay, final volume of gas, there's no water, right? The other thing is, why is it necessary that the gases must be measured under the same conditions? It is necessary because gases expand होती हैं और compress होती हैं. अगर आप pressure change करो, temperature change करो, gases का volume increase होता है, decrease होता है. Do you get my point?
Yes, sir.
So it's important that the conditions remain the same throughout. वरना issue ये होगा कि गैस के मोल्स तो वही होंगे, लेकिन अगर आप टेम्परेचर ज्यादा कर देते तो वही अमाउंट ऑफ गैस जो एक्सपैंड कर जाएगी, ठीक है? So whenever you try to measure the gases, they have to be under the same conditions. तभी वो सेंस बनेगा, वरना वो कंपैरिजन की कोई तुक नहीं होगी. Is that clear?
Yes, sir. And sir, how do we know that CO2 produced was 100 cm cube?
क्योंकि उसने कहा था कि जब सब कुछ हुआ ना, तो he told us that the final volume was 150 cm cube. So we figured out कि final volume of gas was 150. What did it contain? It contained the carbon dioxide that's produced. Water तो होगा नहीं, ठीक है, that's gone. And it's going to contain the leftover oxygen. ये clear है यहाँ तक?
Yes, sir.
फिर उसने specifically कहा कि ये जो gaseous mixture था ना 150 cm cube, when it was treated with an alkali to absorb carbon dioxide, so he tried to remove the carbon dioxide. तो उसका volume decreased to 50. तो पहले 150 था. When he tries to remove the carbon dioxide, volume decreases to 50.
Oh, yes, sir. Got it. Thank you, sir.
चलो ठीक है. So that means okay, the volume of carbon dioxide over here is 100. It's 100 cm cube. ठीक है, that's the volume of carbon dioxide that's going to be present. तो ये हमें मिल गया. So I'm going to rub off the 200 cm cube because that's in excess. That's not the actual amount that's actually taking part in the reaction. But anyways, remember for gases, mole ratio and volume ratio is going to be exactly the same. So we found the volume ratio. Okay, there's a 25 cm cube of a hydrocarbon that reacts with 150 cm cube of oxygen and produces 100 cm cube of carbon dioxide. So what's the mole ratio? Divide everything by 25. What do you get? There's 1 mole of CXHY that is going to react with 25 ratio 150. That's going to be what? 1:6? Is it going to be 6? 150 divided by 25. That's, I think, is going to be 6. So it reacts with 6 O2s and produces 4 CO2s. And we have no idea. Water, we have no idea. We have no information about the water. Okay? So we're getting this. So we figured out the value of X. The value of X is 4. And we figured out the value of X plus Y by 4. That is 6. So x plus y by 4 is coming out to be equal to 6. And if you try to substitute this, to kya hoga? That would be 4 plus, I mean, put x as equal to 4, which is already given. And you solve this. 4 ko le jao, so this would become 2, and you multiply 4 over there, that would become 8. So the answer to this is that the value of x and y is x is 4 and h comes out to be 8. So that's the formula of the hydrocarbon. Okay, so this is what we did yesterday. That I told you that a hydrocarbon can be written as xy. We don't know what x and y is, but you can balance the entire equation in terms of x and y. And if you know the volume ratio, the mole ratio would be exactly the same. बस ये पहले वाले को ना 1 mole रखना है, ठीक है? So 25 cm cube ratio 150 ratio 100. That means one molecule reacts with 6 and produces 4 CO2s. So that means in the equation, the value of x plus y by 4 should be 6, and the value of x should come out to be 4. And you can then solve this. Is this question clear?
Sir.
Clear?
I wanted to ask
Yes.
that जो मोल है CXHY के वो हमेशा 1 रहेंगे मतलब
हाँ, मतलब it's, I mean, the way you've balanced it, ठीक है, yesterday we were trying to balance this equation, ठीक है, the way we've, just 1 second, let the board open. Okay, so let me reload. So what we did yesterday when we were trying to balance this, I told you that, I mean, this equation, if you look at this equation, the first one has to be 1 mole. When you find the ratio should be in a way that the first one is 1 mole and you figure out the rest of the moles. Okay, so you have to do that. So we did do, not sure how many questions we did. We probably just did one. So I'm going to try and so just 1 second. Let me reload this one. So the way we've balanced it, the first one should be 1 moles. Okay, make sure the first one is, I mean, whenever we try to use this equation, the first one is 1 mole. Here you've got oxygen moles, you've got carbon dioxide moles, you've got water moles. Okay, oxygen moles are x plus y by 4, carbon dioxide moles are x, and water moles are going to be y by 2. Okay, that's your general equation of a balanced equation in terms of x and y.
So basically, we're trying to find the moles of the other reactant, right? The mole ratio of the other reactant.
हाँ, कल वाली क्लास ली थी आपने?
नहीं सर, कल वाली मैंने मिस कर दी थी।
उसका
समझ आ गया।
हाँ, बस उसमें ये था कि combustion analysis, whenever you have a hydrocarbon, ठीक है, you burn it, so you get a certain ratio. Okay, oxygen would be this much used, carbon dioxide would be 1 mole, and 2 water molecules. If you burn C4H10, this would be 6.5 O2s, 4 CO2s, and 5 H2s. Okay, every time you get a different ratio, right? So we converted it into a general equation. Okay, I don't know how many X and Y's are. I mean, I don't know it's C3H8 or C4H10 or whatever, C20H40. We don't know what X and Y are. So we made this random equation. By using the ratios of the water molecule and the carbon dioxide and the oxygen molecules, we can figure out the values of X and Y. Okay, that's what we're trying to do. Okay, if we know these numbers, okay, if I know this is 2, so I know that y by 2 has a value of 2. If I know that carbon dioxide is 2, I know that x is 2. If I know this is 3, then I know that this thing x plus y by 4 is basically equal to 3 in the equation. So I can find out what x. So if I know the ratios, I can figure out the values of x and y by just comparison. Okay.
So if it's like 2, the one that you've written above with H2, it's like 2. So that means the y will be like 1.
किसमें ये water वाला this one?
Yes sir, इसमें भी आपने नीचे इसको y के साथ 2 से डिवाइड किया हुआ, तो मतलब y हमारा 1 होगा।
वो होगा कि water के साथ कोफिशिएंट क्या आ रहा है? 2 आ रहा है। इधर water के साथ कोफिशिएंट क्या आ रहा है? That's y by 2. So that means y by 2
होगा।
y by 2 has a value which is equal to 2.
मतलब y would be 4.
ठीक है, so y would be 4, and that is 4. मतलब h क्या आ रहा है? That's 4, right? Do you get the
4,
point?
okay. Yeah, so thank you.
Or मतलब x, so obviously that's 2, so that comes out to be 2. So you can, I mean, for example, over here, it's 5. So y by 2 is equal to 5. So y would become 10. So it is 10. So you can figure by just comparison, if you know the ratios, you can just by comparison figure out what the value of x and y is. Okay, that's the whole thing. You just have to memorize this equation. Now the thing is,
it remains same for all the questions.
For all hydrocarbons at least.
Okay, sir.
But hydrocarbon is that it only contains carbon and hydrogen. If it contains oxygen, then it's not a hydrocarbon. So the equation would be balanced differently then. Okay.
Okay, sir. Thank you.
I'm going to do a bit more of combustion analysis questions. Just a second. This one. So I think we did the first one. I'm going to try and do this one now. So in this one, he's saying there's a hydrocarbon that undergoes complete combustion. So remember our equation. Okay, what's our equation? The equation is CXHY. TK plus X plus Y by 4. O2s produces X CO2s and Y by 2 H2Os. So I'm going to figure out the ratio. So in this question, he's saying that the hydrocarbon is 0.2 moles. TK, the first one, it's 0.2 moles. And then he says that 35.2 grams of carbon dioxide is produced. So I can turn that into moles. That would be 35.2 mass divided by MR, which is 44. So you'll get the moles. What's the value you're getting for carbon dioxide? What is 35.2 divided by 44?
0.8.
And so for this, you're getting 0.8 moles. And the next one is water, 14.4 grams of water. You can find the moles of water as well. 14.4 divided by the MR. Water is 2H and 1O. So that is 18.
0.8. Yeah.
So that is also 0.8 moles. But remember, you can only make the comparison if the first one is 1 mole. You found the ratio. You found the ratio, but it's not a whole number ratio. It's 0.8, 0.2 moles, 0.8 moles, 0.8 moles. But the first one has to be, I mean, turn this into 1 mole. How do you find a whole number ratio? Okay, this would be divide everything by 0.2. If you divide everything by 0.2, what is the ratio that you're going to get? Kya banega? Okay, it's going to be, the first one is 1. This would become 4 CO2s.
4.
And this would become 4 H2Os. Right? That if you burn 1 hydrocarbon, it produces 4 CO2s and 4 H2Os. So what's the value of X? That's 4. Clear? And what's the value of Y by 2? That should also be equal to 4. And that means Y becomes 8. So it's C4 and H8. Is this clear?
Yes, sir, I had a question.
Yes.
सर लेकिन हम पहले से भी तो देख सकते हैं कि जो CXHY इधर ये हमारा ये वाला है, सर फर्स्ट वाला ये तो वैसे भी 1 मोल हमें पता है, उसके अलावा भी तो हम मतलब पता कर सकते हैं कि इसका 1 ही है, क्योंकि उसके आगे हमें कुछ फाइंड करने के लिए बोला ही नहीं है। जी सर, ये वाला
हाँ, ये 1 मोल है, लेकिन हमारी जो डेटा गिवन था वो 0.2 मोल्स के लिए गिवन था ना। 0.2 moles, उससे कहा था कि 0.2 moles हाइड्रोकार्बन होंगे ना, तो they're going to produce 0.8 moles of carbon dioxide and 0.8 moles of water. तो ये होल नंबर, हाँ, तो वो होल नंबर रेशियो होना चाहिए कि 1 मोल, क्योंकि हमारी इक्वेशन तो कह रही है कि 1 मोल होगा तो फिर कितना होगा, तो हमने रेशियो लगा लिया कि 0.2 moles होंगे तो ये होगा, तो if it's 1 mole then it's going to be 1 would produce 4 and 4 of this. ठीक है? Achha, so another question, you look at simple, it's he's just asking, okay, what is the equation? So this is the equation we came up with. Okay. Achha, another combustion analysis, just more questions, just a second. Ahmed Maaz, you clear? Sidra, is this clear?
Yes, sir.
Yes.
So I think no, we didn't do this one. So we're gonna try and do this one. So now remember, okay, this time he's giving you a different equation. Okay, just remember, okay, you just have to find the ratios. Like one molecule is going to burn how many oxygen? Like if it reacts with 5 O2s, then that means the value of Z is 5. And if it produces 10 CO2s, the value of X is 10. And how many water molecules? So you just have to do a comparison similar to the one that we did. So he said that a gaseous sample of T occupied a volume of 20 cm cube. So this is T, the first one, the very first one. And he's saying that the volume is 20 cm cube, I think. Okay, this one is 20 cm cube. And it reacts with, so it reacts with in excess of oxygen. So that's 200 cm cube, but remember it's in excess. So that is not the exact quantity that it's going to react with. And then he says that the final volume of the gaseous sample was 250 cm cube once the reaction was over. So the final volume is 250 cm cube. What does the final volume contain? So now this question is slightly trickier because now the temperature, what's the temperature that's being used? It's 120, right? So is water going to be gas or water going to be liquid? Kya hoga?
Gas.
It's going to be 120, but it's going to be a gas. So the final volume of the gaseous sample, it's going to contain water in it. Okay? It's definitely going to contain water. So what does this 250 cm cube final? It has water molecules, water vapors, TK in gaseous state. Because you have to be very careful with the temperature. It's 120, so it's going to be gas. Carbon dioxide would be produced, so it's going to have carbon dioxide in it. And it's going to have oxygen as well, the leftover oxygen. Okay? So there would be some oxygen present because he's using excess oxygen. So there would be some leftover oxygen as well. So the total volume of the gases that are produced and the leftover oxygen that was added in excess is this thing. Is this clear so far? Saru, clear? Raid, is this clear? Maz, Ahmed, is this clear?
Yes.
Now the next thing is you've got, then he says, he's already stated that under these conditions, all the water present is vaporized. So now he's trying to remove the removal of the water vapor from the gaseous mixture decreases the volume to 170. So you get rid of the water vapors and the volume decreases to 170 cm cube. What does that mean? How much water vapors did you have?
80 cm.
So that means that you got 80 cm cube of water vapors. Okay? Clear? Sidra, is this clear? Ahmed? Then he says,
Yes.
treating the remaining gaseous mixture with concentrated alkali to absorb the carbon dioxide. So he's trying to remove the carbon dioxide now. And the volume decreases to 110. So now he tries to remove the carbon dioxide. The carbon dioxide is gone and the volume decreases to 110 cm cube. So what does that mean? How much carbon dioxide did we have?
60.
So I'm just going to repeat this slowly. Okay, originally your volume was 250 cm cube, all of them together. He removed the water, the volume decreases to 170. So that means you had 80 cm cube of water vapors. He removes the carbon dioxide and the volume further decreases to 110. So that means 170 is 110. He removed the carbon dioxide. So that means 60 cm cube of carbon dioxide is now gone. Baki kya bacha hai jo 110 in mein bacha? What is that? That is the leftover oxygen, right? Because now there's nothing left. Carbon dioxide is gone, water is gone. So the only thing that's left is the 110 cm cube of oxygen. Is this clear?
Yes, sir.
Okay, everyone, Sidra, is this clear? Raid, is this clear? Amna?
Yeah.
Yes.
Okay. So now, let's start with oxygen now. Initially you added 200 cm cube. and there's left over 110. So what is the actual amount that's actually taking part in the reaction? That's 90 cm cube. Because remember, you started off at 200 cm cube, and the final mixture still contains 110. That means 110 of the unused oxygen. So out of 210, 110 is still left. So only 90 took part in the reaction. What's the volume of carbon dioxide? That's 60. And what's the volume of water vapors? That's, I think, 80 cm cube. Okay, so we found the ratio. We found, let's rub all of this. And so we found our volume ratio. Remember, for gases, mole ratio and volume ratio is exactly the same. But according to the equation, the first one has to be 1 mole. So what's the ratio? 20 ratio, 90 ratio, 60 ratio, 80. So if the first one is 1 mole, so that means, what's the ratio that you're getting? That 1 molecule of CXHY O reacts with, I think, 4.5 O2s. That's the ratio that we are getting. What's 20 ratio 90? That's 1 ratio 4.5. And what's the volume of carbon dioxide that's produced? That would be 3.
3.
And the amount of water would be 4. So anyway, so now you just have to do a comparison. X is 3. And y by 2 has a value of 4. So that would become equal to 8. Okay, 2 ko le jao, that becomes equal to 8. So anyways, your answer is that this thing over here is what? It's C3, H8, and it's got 1 O. Okay, that's the formula of this hydrocarbon. The only tricky part was actually figuring out this thing. Clear, Saroko? Is this clear?
Yes, sir. Can you please repeat how you get 4.5 O2?
No, ratio kya hai? It's 20 ratio 90, right? So remember, first one ko divide everything by 20, whole number ratio, okay? The first one has to be made 1.
Sir, what's with O2? Just Z.
Nothing. Over here it wasn't even required. But we did. Z has a value of 4.5, but that wasn't needed anywhere in this. We were able to find the value of X and Y by looking at the products. Is that clear?
Yes, sir.
So in final volume, जिसकी like वो बोलते कि removal of the water vapor, ये सारा ये भी इनके लिखने हैं, मतलब remove होने के बाद भी.
जो water vapors remove हुए कि ये सारा working?
ये just the removal of the water vapor from the gases mix से जो आपने बोला था कि carbon dioxide ये नहीं है.
हाँ, वो इधर कर रहा था ना कि उसने कहा था कि जब ये रिएक्शन हुआ ना, उसने कहा कि 20 cm cube reacts with 200 cm cube oxygen, ठीक है, उसने ये कहा था. But it's in excess का मतलब है कि 200 cm cube सारा रिएक्ट नहीं करेगा. क्लियर है? तो उसने कहा था कि फिर फाइनल वॉल्यूम जो बना था ना गैस का, that was 250 cm cube. तो फाइनल वॉल्यूम was 250 cm cube. तो हमने फिगर आउट किया कि उसके अंदर क्या क्या होगा. उसके अंदर वाटर वेपर्स प्रोड्यूस हुए हैं, वो होगा. उसके अंदर कार्बन डाइऑक्साइड होगा, और उसके अंदर जो बची हुई ऑक्सीजन होगी ना, वो होगी. ठीक है, 3 चीजें. क्लियर है? अब फिर उसने आहिस्ता आहिस्ता बारी बारी बताया कि उसने कहा कि जब फाइनल वॉल्यूम 250 cm cube था ना, उसके अंदर जब वाटर वेपर्स रिमूव किए ना, तो वॉल्यूम डिक्रीज हो गया 170 पे. तो इसका मतलब है कि 250 से 170 पे वाटर वेपर्स रिमूव करने से वॉल्यूम डिक्रीज हो गया. तो इसका मतलब है व्हाट वाज द वॉल्यूम ऑफ वाटर वेपर्स? दैट वाज 80 cm cube, राइट?
Yes.
फिर उसने कहा कि 170 cm cube जो बची है ना, उसमें से ही रिमूव द कार्बन डाइऑक्साइड, एब्जॉर्ब द कार्बन डाइऑक्साइड, एंड द वॉल्यूम डिक्रीजेस टू 110. तो उसका मतलब है वो जो 60 गायब हुआ है, दैट्स कार्बन डाइऑक्साइड, राइट? सो द वॉल्यूम ऑफ कार्बन डाइऑक्साइड इज 60 cm cube. तो एंड में 110 cm cube क्या बचा हुआ है? दैट मस्ट बी द ऑक्सीजन दैट्स देयर. क्लियर है? तो उससे आई फिगर आउट के वाटर वेपर्स कितने प्रोड्यूस हुए थे. आई फिगर आउट के कार्बन डाइऑक्साइड, व्हाट इज द अमाउंट ऑफ कार्बन डाइऑक्साइड प्रोड्यूस्ड, एंड आई आल्सो फिगर आउट के देयर वाज 110 cm cube ऑफ अनरिएक्टेड फालतू की जो एक्स्ट्रा एंड में ऑक्सीजन पड़ी हुई है ना, वो एंड में पड़ी हुई थी. ठीक है, तो वो जो 200 cm cube डाले थे ना, देयर इज 110 दैट्स स्टिल लेफ्ट एट द एंड. इसका मतलब है सिर्फ 90 इस्तेमाल हो रहा है, बाकी तो 110 जाया हो गया, वो तो अभी भी पड़ा हुआ है आपके पास. तो ये वो tricky part था. This was the tricky. This is the easy part. Once you know the ratios, it's very hard. It's very easy actually to find out Find out the value of x and y. This was the tricky part. ठीक है? Is this clear? सारों को clear है?
Yes.
अच्छा, so in questions में he's just asking for that. ठीक है? And I think we did this one question. We did this question. So we can move to this question. ठीक है? Which is kind of the same. First thing is that he's asking for the equation. ठीक है? What's the equation? You already know that. That's going to be x carbon dioxides and y by 2 water molecules. Just make sure always ke what is the state of water. ठीक है? Look at the conditions that he's using. He has stated it's room temperature. The water के state में होगा, it's not going to be a gas. तो अगर वो gas की बात करेगा ना, that would not include water. ठीक है? Is that clear? Because it's at room temperature. But there would be water and there would be y by 2 moles of water, but it's not going to be in gaseous state. ठीक है? Is that clear?
Yeah.
So बस ये what you need to understand is if it's at room temperature, the volume of gas will not include water because it's not going to be in gaseous state. So anyways, what does he say? He says that there's a 10 cm cube of A. I think he's calling this A. This is A, 10 cm cube. That's A. And it is reacted with 50 cm cube of oxygen, and that's in excess. Okay, so again, remember, 50 cm cube is not the exact quantity, it's in excess. इसमें से वो बच जाएगा. There would be leftover oxygen. ठीक है? And the reaction started, it exploded, and 40 cm cube of gas remained after cooling the apparatus to room temperature. So final volume. So what the final volume of gas is 40 cm cube. And he has cooled it to room temperature. So water is not going to be there. वो जो gaseous mixture होगा ना 40 cm cube, that will not have water in it. What will it have? It will have carbon dioxide that's produced. ठीक है? So carbon dioxide होगा इसमें. और क्या होगा? The leftover remaining oxygen. You can remember he's using excess oxygen, so that means there has to be some oxygen that would still be remaining. And so then he says कि जब ये 40 cm cube ना gases was shaken with an excess of potassium hydroxide. Remember, alkali is always added to remove the carbon dioxide. So over here in this statement, when he's reacting with potassium hydroxide, carbon dioxide, remember, is an acidic gas. So जब आप base के साथ react करते हो, carbon dioxide gets removed. So when he tries to remove the carbon dioxide, the volume decreases to 30 cm cube. So what does that mean? How much carbon dioxide did you have? क्या होगा? How much carbon dioxide you got? Anyone? Ahmed, Maz, Sidra? क्या आवाज आई है कि did you understand this or not?
So could you repeat the question?
Question of वही exactly. 10 cm cube of a hydrocarbon was burnt with 50 cm cube of excess oxygen. And then he says that 40 cm cube of gas remained after cooling the apparatus to room temperature. So that means the products are going to be produced when the reaction happens. So the final volume of the gas must contain carbon dioxide. It will not contain water because water is not a gas. So he's measuring the volume of gas. And there's going to be leftover oxygen जो बच जाएगी. तो उसने specifically कहा यहाँ पे, when this 40 cm cube of gas was shaken with an excess of potassium hydroxide, which removes carbon dioxide. ठीक है? You must know.
Leftover oxygen is left.
नहीं, it removes carbon dioxide. तो 40 का जो volume था ना, that decreases to once carbon dioxide is gone.
The volume 10 will be remaining oxygen, right?
नहीं, 10 cm cube carbon dioxide है. देखो 40 cm cube final volume था ना. उसके अंदर से 10 सीएम क्यूब कार्बन, उसने कहा कि 40 सीएम क्यूब गैस थी रिमेन्ड आफ्टर कूलिंग, तो उसके अंदर कार्बन डाइऑक्साइड भी थी प्लस उसके अंदर वो जो बची हुई ऑक्सीजन थी वो भी थी। फिर जब उसने उसको शेक किया ना एल्की के साथ टू रिमूव कार्बन डाइऑक्साइड, तो वॉल्यूम कम होकर 30 हो गया। तो कार्बन डाइऑक्साइड जब बीच में से निकालिए तो वॉल्यूम 30 हो गया, तो कार्बन डाइऑक्साइड का वॉल्यूम क्या होगा? 10 होगा ना।
10 से मुझे लगा वो 30 रिमूव किया, सॉरी सर। वो ठीक है सर।
ठीक है, और जो एंड में 30 बचा हुआ है दैट्स द लेफ्ट ओवर ऑक्सीजन। ठीक है, तो दैट मस्ट बी द लेफ्ट ओवर ऑक्सीजन, क्योंकि कार्बन डाइऑक्साइड भी रिमूव हो गया, सो व्हाट्स लेफ्ट? जस्ट द ऑक्सीजन। ठीक है, तो इसका मतलब है 50 सीएम क्यूब में से 30 सीएम क्यूब ऑक्सीजन डिड नॉट रिएक्ट, so the only quantity that actually took part in the reaction was 20 cm cube. ये मैं लास्ट पार्ट फिर से बता रहा हूँ। ठीक है, फाइनल वॉल्यूम ऑफ गैस वाज 40 cm cube, तो उसमें कार्बन डाइऑक्साइड था that is produced, and the remaining oxygen जो कि excess में यूज हुई है, the remaining oxygen that's going to be there. The 40 cm cube of carbon dioxide, sorry, it's going to be carbon dioxide and leftover oxygen, right? And then he tried to remove the carbon dioxide, and the volume of the gas decreases to 30 cm cube. So that means कि carbon dioxide कितना remove हुआ है? 10 cm cube. So that means the amount of carbon dioxide that was present over here was 10 cm cube. And what's the leftover 30 cm cube? That's the oxygen. इसका मतलब है 50 cm cube जो आपने use की थी ना oxygen initially, there's 30 cm cube that's still left at the end. So that means only 20 cm cube took part in the reaction. Is this clear? Sidra, is this clear? Maz, Raeed, is this clear? Yes or no? Is this clear? As the last part is now easy. Okay, what's the whole number ratio? Like I can get rid of this 50. The whole number ratio is you'll have, I mean, the ratio is 1:2:1. So that means you'll have one hydrocarbon and it burns with 2 oxygen molecules and it produces exactly 1 CO2 molecule. So that means that indicates that the value of X is 1 and the value of X plus 5/4 is equal to 2. ठीक है, ऑक्सीजन को देखो तो x plus 5/4 is equal to 2. So X is 1, take 1 on the other side, it becomes 1 and Y would become equal to 4. So the molecule is CH4 that we're talking about. X is 1 and Y is 4, C1H4. So that's the molecule that we are talking about. Okay, what is the identity of this gas? It's methane gas. Clear? All clear? ये last clear है सारों को? अहमद समझ आया? आमना, सिद्रा?
Yes, yes.
ठीक है, चलो let's we'll do some more questions like these. There are definitely more questions like these in the worksheet. So we're going to try and cover more of these questions. ठीक है, the only tricky part is to figure out the composition of the gases. Okay, how much carbon dioxide you got, how much water you got, how much oxygen you got, and how much hydrocarbon you got. Once you have that, you can just simply find the ratio. And once you have the ratio, you just have to compare. Okay, you'll find the value of X, you'll find the value of all the coefficients and just find the value of X and Y. Okay, so okay, let's continue tomorrow now. Okay, okay everyone.
Okay. Allah Hafiz.
Allah Hafiz.
Allah